We learned how to calculate the range and the interquartile range as a measure of spread, but we said that we have a third option, namely the standard deviation, and we're going to focus here on the standard deviation. So we have three options. We can calculate the range. We can also calculate the interquartile range. So let's write it as IQR. Or the third option is the standard deviation. The problem with the range and the interquartile range is that we only use two data values. Use of two data values. While for the standard deviation, we use all data values, which will give a better view. So we use all data values. And what is actually a standard deviation? The standard deviation indicates the degree to which the data values deviate from the mean. So indicates the degree to which the data values deviate from the mean. Okay, let's check an example. So let's say we have the following values: 2, 3, 5, 9, 11. Since we are interested in the deviation from the mean, let's calculate the mean first. So that is the sum of all the values that we have here: 2 plus 3 plus 5 plus 9 plus 11 divided by the number of values, which is 5. So if we add all this, we get 30 divided by 5 is 6. Okay. So we said we are interested in the deviation from the mean. So to find the deviation for the mean from the mean, we have to do our value. So the first value, for example, minus the mean, 2 minus 6. The second value minus the mean, so 3 minus 6, and then the third value minus the mean, so minus 6. Then 9 minus 11, 9 minus 6, the mean is 6. And then we have 11 minus 6. So those are the deviations from the mean. We have to add them, but if we add them, sometimes we have a negative number, sometimes a positive. They will cancel each other. That's why we take the square of all of them. And we add the square of the deviations. And if we do that, so 2 minus 6 is minus 4 to the power of 2 is 16. And then 3 minus 6 is minus 3 to the power of 2 is 9. So we add 9. 5 minus 6 is minus 1 to the power of 2 is 1. 9 minus 6 is 3 to the power of 2 is 9. 11 minus 6 is 5 to the power of 2 is 25. And if we add all those values, we find that it's equal to 60. To find the standard deviation, we have to do this value that we found, 60, divided by the number of values that we have in our data set, which is 5, and we have to take the square root of this. So that's going to be the square root of 12, which is approximately equal to 3.46 if we round to 3 significant figures. So we can say for a sample of n data with mean x, So for a sample of n data with a mean, the standard deviation is equal to, we call it S. So the sum of the squares, the sum of the deviation from the mean squared, so write that down like this, divided by the number of values, and we take the square root of this. So the numerator that we have here is actually what we calculated here. Okay, and if the standard deviation is small, then we can say that most of the data values are close to the mean. So most of the data values are close to the mean, and if the standard deviation is large, then we can say that the data values are spread out more, like are further away from the mean. So the data values are spread out more.